Is it okay?
Yes,
Voice?
yes, yes, yes.
Yes. Today I'm just going to see in the previous classes I just covered few of the topics like CDC, lint and all. So today I'm going to discuss regarding synthesis. So what is a synthesis? Why do we use synthesis in an industrial for? What is the purpose of a synthesis? All will be covered, and what are the inputs that we are going to give to the synthesis? All will be covered in this class. So the synthesis I just made into two parts, like the introduction part, inputs, and what all the files contained in the input is a one part. And the second part will be like what are the SPC constraints present in this, and how the constraints are used. Everything comes under the second part. So today I'm going to explain you our first part. So let's see. So what all the topics I'm going to cover in a synthesis. So first we'll be having an introduction. Introduction is nothing but why do we use it? What is a synthesis? What is the need of it? And you'll be having a synthesis flow. So for how we have an effect flow in the same way, we'll be having the synthesis. That means a stepwise manner how we go with the procedure. Next, what are the inputs we are going to give to the synthesis? Next steps, how the synthesis is optimized. See, for doing an each and every topic or for each and everything, we will have a stepwise manner. See, for suppose if we want to have a food, we need a plate. On a plate, we should have a food. In a stepwise manner, we'll be going in the same way to perform a synthesis. We have some few steps in which the RTL is optimized and to get a final result. Next, what all the STC constraints we are going to apply in a synthesis and what are the outputs. So this is the agenda. This is a particular agenda which we are going to see in synthesis. So first introduction, that is synthesis. What is a synthesis? Synthesis is nothing but the process of converting high level description language into a gate level netlist. See, mainly high level description language in the sense RTL code. RTL will be given to it. It is a high level description language. This high level description language the tool doesn't understand. So what the tool does, it will convert this high level description language into a gate level netlist. Gate level in the sense in the form of a mark, gate, and what. In that type of thing, it will convert. So the main purpose of synthesis is to convert. It is the nothing but it's the process of to convert high level description language into a gate level netlist. Why do we want to do synthesis? Without doing synthesis also we can go for the next step. So why do we want the main goal? What's the main goal of synthesis? Main goal of synthesis is nothing but to generate a gate level netlist. See, as I told that the high description language will not be understand for the tool, so hence a gate level netlist will be generated and it will meet design specification such as area, power, time requirements. Everything comes under this synthesis. So next I told you synthesis flow. So what is a synthesis flow? I told you for each and every tool we should give a input. So after giving input, what the synthesis, how does it occur? First it reads the input. So whatever the inputs we are giving, firstly it will read the input. Next, after reading what it does, it elaborates it. What does it do? It will elaborate. The next compile, optimization, test to DFT, design for test, and then output. So what all the inputs will be giving. What the tool does, what all the inputs were required, whether it is a .lib file, a SPC file, LF file, text file. So which type of input we have sent, like that it will read. Then it will elaborate. How it elaborates? See, do we want to convert this or how it will elaborate? And next compile in sense it will compile if there is an any mistake or if there is an any syntax, it will compile. The tool automatically compile. Like the optimization will be done. Optimization converting into a gate level netlist and mapping the gate level netlist. Like that the optimizing will be done. And at the final stage, after the optimization, DFT cells were inserted. After the optimization, DFT cells, and finally outputs were obtained. This is the particular synthesis flow. So this is a synthesis flow, but to do this, we will be having different steps like genus synthesis flow, sync generic, sync mapping, sync optimization. These are the four steps which is mainly involved in the synthesis that I'll be explaining in the next class. So just for now, you just go through this flow, but the complete depth of the topic, like gene, what is a genus synthesis flow, what is sync generic, what is sync mapping, what is sync optimization, that those four steps I'll be explaining you in the next class. But first, for today, the introduction class, only this flow is important. Next, what are the inputs of synthesis? I told you that we'll be giving some inputs for the tool, right? So what are the inputs we are going to give for synthesis? RTL code. What are the input? First one, RTL code, library files, STC, Synapse design constraints are nothing but STC, unified power format, that is UPF, physical library files, that is LEF, technological file, that are the inputs of synthesis. Including these inputs, we'll be giving some MMSC files also, and next floor plan def also. All these also come under inputs of synthesis. But mainly, these are the main inputs of synthesis. What are those? RTL code, library files, Synapse design constraint, those are nothing but STC constraints, unified format, that is nothing but UPF, physical library, technological library. Next, UPF will not be for each and every project. See, some project will be of non-aware UPF. In that cases, the input of UPF will not be there. If the project is aware of UPF, that means if the project is related to UPF, at that time only UPF input will be there. If the project is not at all related to UPF, in that cases UPF input will not be there. That there you should be considering it. So these are the main inputs of synthesis. Here you can get, see, still in these three slides, you can get two questions. First question, what is a synthesis? You may get from an interviewer. So how can you answer? Synthesis is nothing but it is a process of converting high level description language into a gate level netlist. So this is the answer. And next, one more question you can get that. What are the inputs of synthesis? So what are the inputs of synthesis? RTL code, library files, Synapses design constraints, unified power format, physical library, technological files. So again, here in these inputs of synthesis, you may get one more question, like whether UPF is present as an input for all the projects. See, if it is an UPF aware, you will be having a UPF as input. If it is not as a UPF aware, you doesn't have an UPF as input. So here you should consider that. So I'm saying this is the RTL library. So what all these inputs, what all the information of all these inputs contain? Let me explain.
Your voice is coming very low.
Now is it clear?
Yeah, now it is fine.
Yeah. So what is the first input I told you? RTL code. So what is an RTL code? It defines the flow of digital signals. It defines the hardware, register, logical operators, everything. This is the information contains in RTL code. So what does the information contains in RTL code? RTL code is nothing but it defines the flow of signal, digital signals between hardware, registers, logical operators, boolean, everything, each and every small information is considered in the RTL code. Next, what is the second input? Library cell. So what is the info contains in library cell? It has info regarding PVT cells, wires, cell delay, and other information. Mainly library files, .lib files or library files contains PVT information regarding PVT cells, wires, cell delay, and other information. Here, cell delay, net delay, all will come under STA. When I go for an STA topic, I'll explain you regarding what is cell delay and what. Next, next, what is SDC? STC means Synapse Design Constraints. What all STC? STC constraints are nothing but it has timing constraints, timing expectation, fan outs, maximum area. Constraints is nothing but for each and everything, we'll be writing some constraint like create clock constraints, generate clock constraints, next set false input. These all constraints will be there in the STC. So why do we use those constraints to run a program or to run a project? We use those. So mainly STC constraints are very important in the synthesis procedure. So what are all those constraints? timing constraint it will be having, timing exceptions like fan out, fan in, maximum area constraints, everything will comes under SDC. Next input is UPF. What all the information contains in the UPF? It has power related, like other multi VVD, low power related information. Everything contains in the UPF. So what all contained in a UPF? UPF it has a power related one. Next, related to multi VDD threshold domain. Everything comes under UPF. And again, low power information also contains in the UPF. So first, what all RTL contains? RTL contains nothing but digital signal between it contains all the information, digital signal, register, mark, gate, everything information contained in RTL code. Next, what are library files contain? Info regarding like PVT cell, cell delay, and other information contains in library files. What are STC contains? It contains like timing constraints, timing exceptions, fan out, maximum area, everything comes under STC. Next, what is an UPF? UPF is nothing but it contains a power related aspects such as multi VDD domain, low power information, everything comes under UPF. Next, after UPF, what we have? Physical library, that is dot left. So what we have? Physical library or dot. It has the information about physical coordinates. Physical coordinates in the sense where the cell was placed, in which layout the cell was placed. All that information was contained in the physical library files. That is nothing but dot left files. And the last one is last input, technological files. Technological file, what it contains? It contains some parasitic information in the sense in which path it goes, in which path it is present. All the sensitive information was present in the tech file. So these are the information which is present in each and every input. So you may have a question like, see what all library file contains. You may have a question from an interviewer like at that time you have to say it contains an information regarding cell delay, PVT cell, wire, and all. So that in that case only I'm explaining each input has what the information contains. Next, they may ask like what is an STC contain, what the input of STC contains. You can answer like it contains timing constraints, time expectation, everything will be there. So learning of inputs is how much is very important. In the same way, what all the info present in that particular info is also very important. That's why I just mentioned each and every input with a info regarding to that. So this is the just introductive topic of synthesis. So what is synthesis and why do we use synthesis? What is the flow of synthesis? What are the inputs of synthesis? And what's the input of what's the input of information of each synthesis contains? So this is the basic introductory topic. When it comes for the next class, I'll explain you how to write an STC constraint. What is a flow of synthesis, like what is a genus synthesis flow, what is sync mapping, what is sync generic, and what is sync optimization. Next, what are the outputs, what are the goals of synthesis, and what are the steps of RTL. We'll be having 3 steps of RTL like EPS, RPS, time stuff. All the depth concepts will be involved in the next class. So only the basic concept was it was a very short PPT. Only the basic concepts were added in the synthesis. When it comes to the next class, all the depth concepts were included. Hence, only the basic were included in the PPT. So, if anyone have any doubt regarding this, you can question so that I will answer you. You can see it.
Yes. Yeah.
Yes.
Just be
So the complete overview is nothing but what's the topic I have told you today. It is a synthesis regarding. So what is a synthesis? Synthesis is nothing but is a process of converting high level description language into a gate level netlist is nothing but a synthesis. So why do we are converting this high level language into a gate level netlist? Because the tool doesn't understand the high level description language. Hence we are converting into a gate level netlist. And next, what is the use of synthesis? Is nothing. The main goal of synthesis is to convert it into a gate level netlist. and to meet that area, power, and timing. So what is the flow of synthesis? We'll be giving an inputs to the synthesis, and what the synthesis tool do? It will read the input, it will elaborate, compile, optimization. DFT is not designed for test, is nothing but DFT, and then output. Next, what are the inputs we are having in synthesis? I have explained clearly in an like before class, and now just I'm giving you an overview. Like, what are the inputs of synthesis? RTL code, library file, STC, UPF, library files, and technological files. So what all the information of each input contains? What all RTL code contains? It code contains like digital signal between hardware, register, logical operators, everything, each and every info contains in RTL code. Next, what are the library files contains? It contains info regarding your PVT cells, cell delay, and other information. What as STC contains? It has a timing constraints, it has a timing exceptions, fan in, fan out, maximum area, everything information was contained in the STC constraint. Next, what is an UPF content? UPF, it has a power related information, and it also contains low power information, low power related information. Next, what is a left file? Left file is nothing but physical library file. What it contains? It contains an information regarding physical coordinates. That means where the cell was placed. That means abstract or overview of a cell. What are the technological file contains? It contains a parasitic information. Parasitic information is nothing but it contains the regarding path. The cell in which path, or any constraints are which path, in which path it is present, from which path it is going. Everything was contained in the technological side. So this is a complete overview of today's topic. So when it go for the next class, we'll be having all the depth topics, which is completely included in the industrial level. So as they are very difficult, hence I didn't add it to the basic concept. When I go for the next, we'll be having a depth topics. Okay, fine. The next class will be day after tomorrow. That will it will be on 13th, and you'll be include it. So kindly please don't miss that class, because all the depth topics were included in this.
Sure. Okay, ma'am.
Okay,
Thank you.
okay, thanks.
Thank you so much.